61 wind chill, temperature 21 below. January 6th, 2014. 7:45 p.m. Very cold. Ready?
It worked.
Did it work?
Math Morning, Mr. Dirk is back at it again. Who knew you'd get some science with your math video? Amazing. And you see what I did there? Negative temperature. Well, today we're doing negative and zero exponents. Let's go. Let's jump right in. So this is going to be review. You should know all this stuff. Let's see here. 2 to the first power. Well, that equals 2. 2 to the second power. Well, that's 2 times 2, and that's 4. 2 to the third power. That's 2 times 2 times 2, or 4 times 2, which is 8. 2 to the fourth power, I'm just taking 8, multiply that by 2, that's going to be 16. And 2 to the fifth power, 2 times 2 times 2 times 2 times 2, or that's 32. All right, so I have all these written down. Is there a pattern? Is there a pattern here? Well, let's see. To get from 2 to 4, I did times 2. To get from 4 to 8, I did times 2. All right, but what if I wanted to go the other way? The other way, Mr. Durkis. Wow, this is crazy. 32 to 16. All right, I divided by 2 there. To get from 16 to 8, I also divided by 2. So the question is, let me tell you this question. What is 2 to the 0 power? So if I follow this pattern, dividing by 2, going back, so I guess I need to divide this 2 by 2. What's 2 divided by 2? That is 1. Wow, bum, bum, bum. So right here, this is a big rule. We call this the 0 power. We call it 0 power rule, but I'm going to say the 0 power equals 1. So whenever you have a number raised to the 0 pattern, it equals 1. So if I have 3 to the 0 power, that equals 1. If I have 90 to the 0 power, that equals 1. If I had, let's see here, negative 526 to the 0 power, that also equals 1. So this is an important rule you should know. Whenever you have a 0 for an exponent, it's going to equal 1. Do you feel like getting crazy? I do. So let's continue this pattern. Let's go back a little bit more. If I continue, I would have 2 to the negative 1, and then 2 to the negative 2, and I can even fit in 2 to the negative 3. So what are all these going to equal? Well, if I go back, I divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. So if I want to go back one more, I can divide by 2 again, and I take 1 divided by 2. If I want to go back one more, 1/2 divided by 2, that's 1/4. If I want to go back one more, divided by 2, it becomes 1/8. All right, so what is this pattern really? Well, this is really 1 over 2 to the first power, right? Instead of this negative 1, if I put on the bottom and make it a positive, that's the same answer. Over here, this is 1/4. That's the same as 2 squared. So, 2 to the negative 2 power is the same as 1 divided by 2 to the positive 2. So you make this negative positive, put it on the bottom. And lastly, we've got 1 over, this can be 2 to the third power, right? 2 to the negative 3, 2 to the positive 3 right there. Whew. So we've got the 0 power rule and we've got a negative exponent rule. Wow. All right, let's do some examples. Rewrite using positive exponents. So we've got 5 to the negative third power. So the rule says you put a 1 on the top, and the bottom you make this positive. So 1 over 5 to the third power. Bam, done. All right, over here we've got x to the negative fifth power. Same rule, 1 over x. Instead of negative 5, we make it positive. 1 over x to the fifth power. Whew, not bad, not bad. All right, 3 to the negative 2. Well, let's see. It's going to be 1 over 3. Instead of negative 2, I put a positive 2. Not bad at all, right? All right, this one can get a little tricky. I've got 2y to the negative fourth power. There are no parentheses, so that means the 2 is not being taken to the negative fourth power. So the base is y, and the power is negative 4. So what happens is the 2 stays the same, and the y, right, that's what's getting changed. So it becomes, this is being multiplied, because when the number is next to the letter, it's multiplied, to 1 over y to the negative, not negative, positive 4. So 1 over y to the fourth power. And the way we really want to write this is 2 over y to the fourth. Why this instead of that? This is kind of messy, right? You can really just multiply this out. 2 times 1 is 2. 1 times y to the fourth power is y to the fourth. This is kind of showing you the steps in order to get this final answer right there. Let's do some more. So we've got a lot going on here. We want to simplify, then rewrite using positive exponents. I'm looking at this. I see, okay, there's a positive exponent there, but this one is a negative exponent. So I'm going to write it a little differently. So 2, and this is really 2 times x squared, right, multiplied. This becomes 1 over y to the third power times z squared, right? So I try to find the negative exponent, and then I write it as a fraction. And the way I want you to write this is technically correct, but it's just ugly, right? So everything that's being multiplied, you can put that on top of the fraction in the numerator. So we have 2x squared, and then we have this z squared. And then on the bottom, right, this is 1 divided by y cubed. You just put the y cubed on the bottom. So basically, you're going to make this a big fraction. If you have a negative exponent, you bring it down to the bottom. And that's how you do it right there. Same with this one, right? I'm looking at, we got a negative exponent there, a negative exponent there. So I'm going to make a big fraction. I call them a super fraction. I have 1/4, right? So 1 will be on the top, 4 is on the bottom. A to the negative 2 power. All right, that's going to go on the bottom. A squared, I make it positive. B to the fifth, that goes on the top. A B to the fifth. And C to the negative third, that goes on the bottom. C to the third, I make it positive. Ba-bam, spladow, there we go. And if you don't want this one, you can get rid of it. But everything else is good. Let's get a little crazier. Let me drag it this way. Whoop. All right. So this one has an exponent. So remember this rule, GEMDAS? So what should we do first? When you have an exponent, that means you multiply. So I'm going to take this exponent and multiply it by these exponents. But first, I need to do this 3. So that becomes the 3 squared. X to the negative third squared becomes x to the negative 6, because I did negative 3 times 2. And then y to the 0 power, 0 times 2 is just 0, so we have y to the 0. If I simplify it, 3 squared, that's 9. Okay, let me do with this, 1 over x to the 6th power, right, because it's negative 6. Y to the 0, that equals 1. So that's really just multiplying by 1. So I don't really even need to write that. I'll just leave it out. And this simplifies to 9 over x to the 6th power. Bam. Beautiful. Beautiful math. All right, one more. All right, big one again. Looks like we got a multiply symbol. So when I multiply, what am I doing to the exponents? I'm adding if they have the same base, right? So I see you got an m there and an m there, and then I'll give a squiggly line for the n and a squiggly line for that n. All right, so m to the 4th, m to the negative 3rd, right? I'm adding these. 4 plus negative 3 is just 1. So that's m to the 1st power. Now I have n to the 1st times n to the negative 5th. 1 plus negative 5 is negative 4. So that's n to the negative 4th power. And my coefficients 2 and 3, I just multiply them. 2 times 3 is 6. So now if I want to rewrite this, I've got 6m. I don't need to write the 1 anymore. And when you have a negative exponent, you put it on the bottom and make it positive. N to the 4th. There we go. 2 more examples. This time, this one looks like we're dividing. So if I look at my old GEMDAS friend, when we divide, we are subtracting the exponents. So let me take a look over here. First thing I have this 4 and the 2. All right, let me simplify that. 2 can be divided into 4 twice, and 2 divided by 2 is 1. All right, cool. Now the x's. So we have 2 minus 5. So these are the x's, right? We have 2 minus 5. 2 minus 5 is negative 3. So be careful. Don't do 5 minus 2. You take the exponent from the numerator and subtract it by the denominator. Now let me check out the y's. So this is y to the negative 3rd, and then divided by y squared. So we've got negative 3 on the top, minus 2. Careful with the signs. Negative 3 minus 2 is going to be negative 5. So be wary of your exponent signs. If it's negative, it's positive. Lastly, we have z to the 4th in the denominator, right? You could always write z to the 0 on top. Why? Because z to the 0 is 1. So that's going to be 0 minus 4, which is minus 4. Okay, so these, I simplify that. So if I write this, 2 over 1, that's really just 2. So we have 2 times x, right? We said that was negative 3. Y, we said that was negative 5. And z is negative 4. So these are all negative, so my fraction, my superfraction is going to be 2 divided by all these things, but with positive exponents. X cubed, y to the 5th, z to the 4th. Bam, done, happy face. Well, let's keep rolling. What is behind this magic door? Dun dun dun. Hey, this doesn't look so bad. All right, so what do we got here? This is an exponent outside of a grouping symbol. So when you get an exponent, we're going to multiply. All right, so let's see. Remember, we got to do it by everything, right? If it's 0 out here, everything on the inside. So it becomes 2 to the 0 power. X is really x to the 1st. So 1 times 0 is 0. And then y to the 7th. 7 times 0 is 0. What is that? Well, all right. 2 to the 0 power is 1. X to the 0 power is 1. Y to the 0 power is 1. 1 times 1 times 1 is just 1. That was easy, right? You could look at it too. If anything to the 0 power is going to be 1. So you don't even have to look at the stuff inside. Just know if you have a 0 on the outside of an exponent, and that's the power, it's going to be 1. Ooh, bringing the pain. We're bringing it. We're bringing it. And just so you know that we're bringing the pain, We got my man Ronnie Coleman from the last video. Right? That's what happens when you lift all that weight. You look like that. But let's give him a little upgrade. Let's upgrade my man Ronnie. Bam. Bringing the pain for real now. So how are we going to do this one? It looks like a lot, right? We can do it. We just got to follow our rules. So what should I do first? How can I attack this? Well, let me follow GEMDAS. Do I have any grouping symbols? Yes, I do. Can I simplify anything inside there? No. What about exponents? I got an exponent everywhere, but this one is outside the grouping symbols. So let me do the exponents first. And you see a lot of these negative ones. Let's wait until the end to do the negative exponents. So I have this exponent, this 3 outside of these parentheses. So that means I'm going to multiply. Okay, so let me do that right here. 2 to the third power. All right, that is, I'm just going to write 8, right? 2 to the third power. 2 times 2 is 4, times 2 is 8. And then I have x, this is really x to the first. So 1 times 3 is 3x to the third power. And then I have y to the fourth. 4 times 3 is 12, right? So y to the 12th power. And that's being multiplied by this, right? So I'm going to write multiplied. I can get rid of the parentheses because there's no exponent. So 3x to the negative third, y squared. And I'm going to write this just for good practice. 4x to the negative third, y to the 0 power. All right, what do we got now? This is a multiply, so I'm going to multiply. Let me change my color too, just for fun. So when I'm multiplying exponents with the same base, I'm going to add their exponents. Okay, so I have 8 times 3, that is 24. Now I have the x's, x cubed, or x to the third power, and x to the negative third power. So that's going to be x 3 plus negative 3. That's the same as 3 minus 3, and that is 0. Now the y's, we have y to the 12th and y squared. 12 plus 2 is 14, so y to the 14. And that's all over 4x to the negative 3, y to the 0 power. Let me change my color one more time. There we go. So now I've got the numbers, the coefficients, the x's, the y's, and I'm going to divide, right? It's a quotient. 24 divided by 4. Okay, I can just divide that. 24 divided by 4 is 6. Okay, now the x's. When I'm subtracting, or when I'm dividing exponents with the same base, I'm subtracting their exponents. So I have x to the 0 power minus x to the negative third. So that's really 0 minus negative 3. Because 0 is on the top, the numerator, negative 3 is in the denominator. Minus negative 3 becomes positive, so it's just 3. So it becomes x to the third power. And now with the y's, we got 14 minus 0, which is just 14. So we have y to the 14th power. So that's it. We did it. This is the answer. So good luck on the mastery check. Good luck with this packet. You got it. I'm going to leave you with this video I found the other day. You might not like it, but I like it. So it's cool. Dirkus out.
Gotta get my cat a bath. One time, I gotta get my cat a bath. Check it. One, like rubber duh. Gotta get my cat a scrub. Ravioli acting like they know me. And I'm sorry if the sun gets coldy. Look sharp than that. Now everybody screaming, let's adopt the cat. I'm sorry, I gotta keep you clean. Ravioli, please don't treat me mean. Cat people, put your hands up. Where you at, baby? Just stand up. Look, I tell them to plan up. And we coming real wavy. Everybody knows cat ladies drive me crazy. And I'm sorry, one time and you climbing on my hat. you like me like that. Hope you like me like that. Look, don't try to sit home. Don't leave me alone. Daddy never come. You're not a dog, not gonna throw you a bone. And we never hit me real clever, shining any weather, shining together. Cat people stand up, now or never. Bye, we love you. I gotta clean him right now, and he's not happy. But we love you so much. Happy Cat Day! Say hi to Ravioli. Happy Cat Day, chilling on a Saturday. And we got a bad weather day. Alright.